So, welcome back to our next keynote speech by Jocelyn Maclure. He is currently the Jaroslawski Chair in Humanity and Technology at McGill University. Moved there a couple of years ago from the University of Laval, where we met earlier. Actually, Jocelyn, reviewed one of my books for Canadian radio. And then we got in touch, I heard what he had to say, and so we started a conversation about like realism and things of this form. And Jocelyn has been a long-standing conversation partner for me in the realm of social philosophy. So that's why, I had the chance of provoking him this morning as much as I could to see what's coming out of that.
I'm still here.
Yeah, he's still here. But he also provided me, so I thank you a lot for this, and it's very clear in the book that I finished recently at McGill when I was there visiting the chair last year, the Ethical Capitalism book that some of the Japanese people might already know. And so I finished writing the book at McGill, having long conversations on social freedom in particular. So I owe my version of social freedom to discussions with Jocelyn in particular. Already, during the pandemic, we also talked about those kinds of things. He has written also widely on the issues of public relevance and interacted for quite a while with the policy world as, in the ethics advisory board for ethics and technology in Quebec. So Jocelyn also really interacted with other sectors to see what we can learn from ethics and what ethics brings to these contexts, and also has been thinking a lot about the Quebecois position. So issues of multiculturalism and all of this, and long-standing conversations also with Charles Taylor, who has been a fellow traveler of yours for quite a while, and thanks to Jocelyn, we also had a wonderful encounter with him last October. He's in amazing shape also,
Absolutely.
Just intellectually. So this is where Jocelyn is coming from, and being at McGill last October, I witnessed really outstanding social thought. It's in very good shape, and in the political science is great right now. The philosophy department is very good, and but there's a whole constellation, so we have been discussing ethics of AI. In that respect also for a couple of years now. And Jocelyn was also a visiting professor in our Mercator project that we run together with the University of Cambridge on desirable artificial intelligence. So I thought, what better speaker on the kinds of things we're discussing here than Jocelyn. So welcome to the new school. Looking forward to what you have to say.
All right. Okay, well, thank you so much, Marcus, for this very, very kind invitation, and discussions that we've been having for more than a decade now are very precious to me as well, and they help me, shape my own views in different branches of philosophy. So I'm very deeply indebted to these conversations, and thank you to Paul and Zed also for this very kind invitation. It's really a pleasure to be with you and an honor. Okay, so. I want to talk today about, it's a seminar on the limits of intelligence, different kinds of intelligence, and so I want to talk about the epistemic capacities and limitations of the best AI systems that we know today. AI systems that are all the best ones, right, based on different kinds of deep learning algorithms or deep artificial neural networks, including the LLMs, right, that we talked about in the past few days, and how they compare with the human mind and human cognition in general. Okay, so that's the topic, but there will also be an ethical aspect to my talk, as I believe that the proper understanding of both the capacities and limitations of the best AI system indicates a way that we should think about how the ethical question of how to lead a good life, right? So, and how should we integrate AI systems, if we should, under which conditions, and how we should regulate also AI technologies, because they create many very, very important risks. And that's the current AI systems, right? They create very important risks, potential harms, and we, I think, need to be very serious about how we regulate them. So the epistemic and the ethical will be intertwined in my talk. Okay, so first distinction. When we talk about the philosophy of AI and the ethics of AI in particular, we need to be clear on what kind of AI systems are we talking about, and sometimes we're conflating these two kinds of AI system, especially in the ethical discussion. So I think that we should distinguish between actually existing AI systems, right? Those that are being deployed in pretty much all areas of human life, right? From the most intimate one to the most political ones. And these, as I said, are based on different kind of deep learning algorithms. So these are what I call state-of-the-art AI systems. They actually exist now, and they keep improving them. But very often when we talk about the ethics of AI, we're talking about possible AI systems, right? Where there's a future logically possible worlds where AI would be much more powerful than what we know now. And it's totally, this possible world are totally conceivable, right? We saw progress in AI research and development in the past few years, and we could witness other new kinds of progress. And sometimes we just when we're thinking about the risk, we talk about not yet existing, but logically possible AI system, okay? Possible AIs include what they call AGI, right? Many AI researchers and developers that's what they're aiming for, right? Artificial general intelligence, and so that's human level AI, as you know, or even beyond human level artificial intelligence, right? Super intelligence and so on. And as we will see, many top AI researchers, but many also scientists and philosophers think that it's not only conceivable, it's not only logically possible, but it's actually very plausible that we will reach AGI, right? That's a very influential view in this domain, okay? And other kind of possible AI, that doesn't exist, as at least that's my view, but that is always very often conceived is like strong AI, and I'm referring to how John Searles used it. So these are AI systems that are actually minds, artificial minds that think, that understand, as we discussed this morning and yesterday. They could have subjective experiences. They could be conscious or even sentient. And those, they can go together, right? You can have an AGI that is or is not conscious, right? You can have a very powerful cognitive system that doesn't feel anything to be in their state, but they're very cognitively powerful. They can do many tasks, beyond their performance goes beyond what humans can do without feeling anything. Or you can think about AI systems that are still struggling with some cognitive tasks, but that would, maybe consciousness emerge in these systems also because the right conditions were there, right? When that Google engineer said that he thought that one of the earlier language model was conscious, that's a possible scenario also, okay? So this is not what I want to talk about today, but if you think that these are very serious possibilities, both strong AI and AGI, then the ethics of AI becomes predominantly about these issues, right? The value alignment problem. How do we control, cognitive systems that are maybe more powerful, accurate, and so on than us? It would be a legitimate question, right? If I thought that we were moving towards AGI, I would work on the value alignment problem as well, and that could create an existential risk, right? According to them, including for a while it was people like Nick Bostrom and so on, right, who were holding these views, or our friend David Chalmers and so on. Now it's top AI researchers also, since the emergence of large language models. My colleague in Montreal, Yoshua Bengio, one of the Turing Prize winner, now is very, very concerned about how we will keep control over the best AI systems. So he had what some call his Oppenheimer moment, right? He's very concerned about the technology that he helped create. And if we thought that conscious AI was also a real possibility, then we would have to worry quite a lot about their moral status, right? Their moral standing. Do they have intrinsic moral worth? If so, we should extend rights to them and so on. But I don't think that we're moving closer to both AGI and conscious AI. So that's not what I'm mostly concerned with. Okay, and this should be distinguished in the ethics of AI with all the ethical issues raised by the way that we use the best machine learning based systems, right? And you heard many of these issues and risks and potential harms in the past 7 or 8 years. I'm not gonna review that list. It would be too long. But I think that, well, I know that 2 of my papers, I think, were circulated. One of the explainability problem and one of the bias, fairness, and discrimination problem. So that's the kind of practical ethics or applied ethics of AI now. It's about the different risk and issues raised by the best machine learning based systems, okay? So some of my work is in that field, and many of my grad students at McGill are working on different issues related to actually existing AI system. Okay, so I told you that the strong claims made about the near future of AI, these are not marginal like fringe views in the field. So Jeff Hinton, probably he's often referred as the godfather of AI. That's not accurate, but he's one of those who thought that connectionism or deep learning, machine learning was the way to go in AI, even when it wasn't a thing, when it wasn't popular, it wasn't working very well because they didn't have enough data and enough, powerful enough computers. It wasn't working very, very well. But he thought that artificial neural networks was the way to go, and that the symbolic AI was a doom paradigm. So he's one of the pioneers in deep learning, that's for sure. He had Yann Lequin and Yoshua Bengio as postdocs in Toronto before it really took off, okay? So he resigned he's at the University of Toronto, but he had a position also with Google. He resigned like after ChatGPT also. He got also very concerned. And he gave that interview to the Globe and Mail, right, a Canadian newspaper, and he said, so that's the kind of the journalist quoting him. Yeah. So what I want to talk about is the issue of whether chatbots like ChatGPT understand what they're saying. A lot of people think chatbots, even though they can answer questions correctly, don't understand what they're saying, and that it's just a statistical trick, right? That they're just stochastic parrots. And he says that's complete rubbish. They really do understand, and they understand the same way that we do. Okay, so that's his view that he expressed very recently. Okay, so I figure that that's a kind of a different position, than the one laid out, say, by Marcus today. Was I say, okay, maybe they understand, but not the way that we do, right? You were very clear on that. Yeah. And that's interesting for the philosophers, right? Isn't any spooky stuff in the way the human mind works. He said by spooky stuff, he meant secret or mysterious mental processes that couldn't be analyzed and transformed into replicable actions, right? So he's a reductionist about mental content and processes. So he says, I don't buy spooky stuff. I think it's rubbish. I think it's just a denial of the fact that we're material, that we live in a material world, right? So we know that story. And once you have these views, then you worry about the existential risk, right? Because they are minds and they might surpass us, okay? So 2 theses that I want to not fully defend. Well, that I want to sketch. I'm gonna linger on the second one. I won't have time to try to defend the first one, but these are the two theses that are doing the work in my position. Okay, so the first one is about the distinctness of embodied and embedded human intelligence. Okay, so that's not what I'm gonna focus on, but maybe that's what I should, given the discussion that we had so far. But it's kind of among the premises. So I see human beings, being embodied first, right? And also embedded in both natural and cultural environments in which we act in meaningful ways, okay? So that's the distinctness of embodied and embedded human intelligence. I think that it should be, that form of intelligence should be distinguished from artificial intelligence. And the second one is a view, and that's the intersection of epistemology and ethics. It's the view that even if we do recognize, and we should recognize, the very real limitations of the human mind, that acknowledgement doesn't justify either inflated views of the capacities of the best AI systems that we know, and it doesn't justify laxist or lenient positions about the kind of normative standards that we should uphold when we think about integrating AI in our life and how we should regulate and govern AI technologies, right? Recognizing the limitations of the human mind doesn't justify a lenient view about how we should integrate and regulate AI. So that's I want to focus on that second view that I try to defend in different ways. Oh, what did I do? I don't know if someone can help me with this. Thank you so much. Okay. Yeah, so now I'm going to focus on the second one. It keeps, oh no, it's just my screen. Oh. Okay, so I've been defending the first view for some years now. I'm sorry, I don't see the slide on my screen. Okay, now it's back, but it keeps going away. Okay, so while we're trying to fix that problem, so the first view is grounded in something like, yeah, okay, right. So in order to defend the first view, I'm not going to focus on it, but it's based on a form of biological naturalism that was defended by people like Searle, but also, as we said this morning, by a particular approach to cognition that sometimes we call triple E cognition, right? Embodied, embedded, and inactive cognition. So that's a kind of, views in cognitive science inspired by phenomenology, okay? So that's what's doing the work in the background. Now, let's review how the best AI system that we know actually work, how they operate, and that they often, produce outputs that are deemed accurate or good or useful, and sometimes even better outputs than what humans can produce. So there are different AI systems that are powered by machine learning algorithms, right, and that we use in different ways. That's not maybe a comprehensive kind of taxonomy, but the most prevalent one are what you call decision support systems. So all the predictive algorithms that we use to either make decisions or to replace or emulate human judgment, right? So that could be a diagnostic tool in healthcare, or AlphaGo, that's able to better figure out how the different moves that we should make in a particular game. So these are decision support system, and these raise very important ethical questions, because we can use them in the judicial system, or the police force can use them, or governments and or companies when they hire people, and so on. We are constantly exposed to the content recommended or chosen by what is called recommender systems, right? Again, these are the same kind of predictive algorithms, but that are used to recommend contents to user of different search engines or social media platforms. And the goal there is to make us use these platforms, to stay on the platforms, right? To kind of capture our attention. That's the attention economy. But these are very quite prevalent, right? So when you think about all the content that you're exposed to in a given day, lots of that content, right, in as much as you were online or using a search engine, or increasingly now a generative AI, very often the content was selected by a predictive AI algorithm. And now, on top of these two kind of systems that we've been using for some years now, we have a more kind of visible one, right? The generative AI systems like ChatGPT, or different systems that generate images or sound, music, movies, and so on. That's another kind of AI system, right? But that we're using increasingly, and that is likely to play, a growing role in our life. But they are all based on the same kind of deep learning system. So we need to understand both the capacities and the limitations of these systems. My view is that there are some basic limitations, that are rooted in the very foundations of these systems. And that these limitations are not, as far as we can tell, like temporary glitches or bugs that are likely to be solved with more data or more computing power, or with ingenious tweakings of the model. I think that they're rooted in the very foundations, and we need to understand them. Okay, so how do they work? One way to understand, what's common across these different AI systems is that they're based on artificial neural networks. And as you well know, these systems are designed to try to identify patterns in very, very large quantities of data, right? So that's well known now. So as Kaplan writes, they don't learn how to do things in the common sense of the phrase, developing a principled understanding of the underlying relationship and properties of their world. Instead, they are incredibly skilled mimics, finding correlations and responding to novel inputs, as if to say, oh, this reminds me of, and in doing so, imitate successful strategy gleaned from a large collection of examples. Okay, so I want you to keep this in mind, because even with all the creativity put into how generative AI systems are built, and now this is the basic foundation, right? They are still deep learning algorithms, and the idea is to track very, very, very large patterns in the data set. The data set sometimes now being the entire internet, and then when you use them, the idea is that they try to spot, okay, were there like significant patterns in the data, and the new input in the system, does it is it similar to some of the patterns extracted in the training phase? Okay, so that's still how these systems are built. Okay, so these systems have different properties. They're all probabilistic, right? It's all about making a probabilistic, judgment about, whether a particular image, is there a cat on that particular image, or, trying to infer probabilistically what should follow a given string of words if it's a large language model. So it's all about, probabilistic inferences, and it's stochastics, right? There, if you prompt your LLM, the same way, you ask the same prompts at different times, you might have slightly different answers. You never really know. Sometimes it will be pretty much the same answer. Sometimes it will vary. Sometimes I test them by asking a question on Rousseau's moral philosophy. Sometimes it gets it wrong. Sometimes it provides better answer. So there are many variables there, but you won't always have the systematically the same answer, okay? They're all predictive, like the outputs of the system, they're all predictions. It's all about inferring, what's the most likely answer to a particular, question or input from the pattern seen in the data. So these are probabilistic inferences, right? Not logical inference, but probabilistic inferences. That's why sometimes also they get things wrong. And it's all about tracking correlations, right? It's not designed to say, oh, look, there's a causal relation here in the data, right? So I know what's the answer because I can track causality. It's never tracks directly causality. It's all about tracking correlations and matching, different patterns, okay? So that's basically how these system works. I like to say that they are massively inductive, right? Because the amount of examples of cases that they can process is just mind-blowing. So these are massively inductive machines. But once you figure that out, you kind of know already what will be the limitations, right? Because they are massively inductive. Sometimes they will have problem generalizing, right? Because they still face the basic problem of induction, right? They will get things wrong very, very often, but sometimes they will get things wrong also. And the problem now is known as the overfitting problem, and it's all about how to generalize outside the distribution, the data distribution seen in the training phase, right? There's a data distribution there. But when you use the AI in the real world, sometimes you'll have data points that, were not there, or maybe in real life they are significant, but they were kind of outliers in the training phase. The AI is not able to process accurately the data that that were not kind of included in the data distribution, right? So it's a generalizing, in all kind of circumstances is often difficult, right? And so that's one of the cause of the basic limitations of the best AI system that we know today. And here, my view is that I don't see how we will overcome these limitations without changing the paradigm. Okay, so that's the view that seems the most plausible to me. So one popular approach in AI now is AI scaling, right? So you always want more of data, more computing power. And that at some point, because it worked in the past, right? So AI did advance massively in the past 15 years, and scaling was integral to these successes. And something, well, that's what they call the bitter lesson, right? We try to design fancy algorithms, but what we need more data and computing power. I don't think that doesn't solve the induction problem. And I also don't think that kind of rather ad hoc human intervention on top of the deep learning system will solve it. And here, what I have in mind are all these clever approaches now being deployed by AI programmers. These are, for instance, so once you have your deep neural network, right, you add kind of other layers or modules or sometimes just patches or filters, and then you try to improve, right, the quality of the output through adding kind of other layers on top of your deep neural network, okay? So that would be, for instance, one approach now that is pretty much universal is reinforcement learning from human feedback, right? So you have your deep learning model, then you had another layer where it generates all these outputs, and then you have human evaluators, kind of assessing the quality of the answers to your prompt, right? Thumbs up, thumbs down, and that your AI can learn from how the human assessors assess the outputs, and it kind of learn. Okay, so this is generally seen as a good answer by humans. This is generally seen as bad. So it improves, marginally at least, the quality of the output. And you can think of many other such approaches, and very often it will be like kind of filters, right? We very unfortunately, many large language models sometimes are very inappropriate, right, in the kind of answers that they give to prompt. So at some point you just say, okay, we'll just put a filter. So if we ask them, to do things that are not seen as appropriate, there will be a rule there. It's not about learning. It's just a rule saying no, you don't answer to sexually explicit, say, prompts. Or if the human asks you to be racist, well, no, this won't be possible. And that's kind of a patch, right? We know there's a problem. We don't know how to make them, appropriate in these circumstances. So we'll add a filter on top of it. Okay. Of course, a very troublesome, issue for the best models that we know now is what is called the hallucination problems. I don't think that they are like real hallucinations, right? That's a form of anthropomorphism again, but at least we know that sometimes they make stuff up. Right, so they give highly plausible answers, but sometimes these answers are factually inaccurate. But they are, the chatbots are asserting, right? You ask them a question and they assert, right? They give you, well, this is the case, or this is the answer to your question, and sometimes it's just confabulation, right? And that's hugely problematic if we're going to rely on these systems for performing many tasks and sometimes for replacing human, right? And that hasn't been solved yet, the hallucination problem. So what is missing? I think that there are different modalities of human reasoning, for instance, that these systems do not have, both logical reasoning from either logical rules or from principles, trying to reason deductively, for instance, or causal reasoning and so on. This is escaping the best system. And I also think that they are very inept at practical reasoning, right? Practical reasoning, among other things, is about how to connect, say, the general, let's say a law or a principle, for instance, and the particular, right? When you need to reason practically, it's because you have to figure out how you should act in the particular context, right? And when you really need to reason practically, the situation is complex, right? You're not sure what's the best course of action or what's the just course of action and so on. And you need to connect maybe, say, values, principles, laws, and so on to a new situation. And that's not how the best systems work, right? And it cannot compensate by relying on a form of what we call common sense also, right? That would be very useful. But if we define common sense, as a kind of faculty, very close maybe to intuition, but you'll tell me what you think, where, you don't really need to deliberate deeply to know what's appropriate or what you should do, right? It's commonsensical. You find yourself in foreign countries, in a culture that you don't know too well. In many cases, you will kind of know how you should act, not to be offensive, and so on. even if you don't have what it takes to reason, and sometimes, just as when I think it was Gemini or recommended adding glue to the pizza, the cheese in the pizza, because we would know that, okay, that was on a Reddit thread somewhere. We know that it's nonsensical, right? We don't need to think about it, but it doesn't have common sense. And AI researchers are working on trying to solve the common sense problem. And I think that these different capacities that are evading AI now are derived from our embodied intelligence and this intentionality that we discussed this morning, the fact that our senses connect us to the world, to what exists in external reality in a way that is much more direct than for AI systems processing symbols or numbers or vectors or what have you, but that are not connected into the world in the same way. Okay, so I think that this is still missing. And actually today I stumbled on that paper recently published in Nature, saying, arguing, demonstrating, they tested the models and they said the larger and more inscrutable language models become less reliable, right? So I need to look at the detail, but they say that scaled up and shaped up models tend to give an apparently sensible yet wrong answer much more often, including errors on difficult questions that human supervisors, right? So that's the reinforcement learning from human feedback. Sometimes human supervisor will not even see that there was a mistake or an error. So again, the point here is that we need to be very, very careful if we think that we can rely on these systems, okay? These, I think, now are basic limitations, and I'm not seeing now, scientific breakthroughs of how to really go beyond or solve these issues. So these are like basic epistemic limitations, right? They are things that the best AI system cannot do because of these limitations, but I also think that they're connected to the ethical risk that they create for us, right? Because these risks are also derived from the way that they work, the fact that these are these opaque machine where even if you look at the code, right, you cannot extract a piece of reasoning or a set of justification for a particular output, right? It's not there, it's not in the code, and so on. So many of these problems are also derived from how they work. The fact that they track patterns in the data. Sometimes these correlations, what they track is actually, past or present injustices, right? And if you use them then to decide who's eligible for bail, for instance, or and so on, well, maybe it will generate biased results. Okay, so it's connected to how it works. So my approach in AI ethics is to now plead for the development and implementation of what I could call a demanding institutional ethic of AI, right? So one very popular move in AI ethics now is to say, well, we have to make the developers more ethical, right? More virtuous, or to make the companies themselves more ethically, like socially responsible, and so on. I don't have anything against that project, but that shouldn't be our main focus, and that's not what's most urgent now. What is most urgent is actually institutional answers to these problems, and institutional answers for me include both the necessity of coming up with binding legislations on AI that create new legal obligations for the developers of AI technologies, and also legal obligations that will kind of constrain the developers to, rethink the way that they design the systems and implement at the organizational level new processes and rules and mechanism to reduce the risk created by their system. Okay, so that's AI's ethic institutional turn. So I could say more about it, but I don't have time. What I want to focus on now is how this kind of demanding institutional ethics is sometimes challenged in the literature. And yeah, so I think that there are a few moral and political philosophers, adopting that approach in AI ethics. And my colleague, not McGill, but then a colleague with whom I meet often in AI conference, Kate Vredenberg from LSC. She has that great paper on the right to explanation for those who are subjected to AI-based decisions. In that paper, in my paper, I defend what I call a strong explainability requirement, right? So those who decide to integrate AI in their decision procedures should meet a strong explainability requirement, should keep the capacity to explain and justify their decisions when these are ethically high-stake decisions. Okay, so that's a demanding institutional approach to AI ethics. But it's, and we could say the same with AI fairness problem and so on. But the last part of my talk is about how this kind of demanding ethics is often challenged in the literature. And then it's about, going back to the human mind and to human cognition and drawing an analogy with our very real also cognitive limitations, right? And I think that there are two very interesting ways that can be done. One is by drawing on the bounded rationality literature, and the other one, and I see it's gaining some traction now in the field in social epistemology, right? In the first, the bounded rationality argument comes from cognitive psychology, behavioral economics, and so on. But the second one comes from social epistemology, and it's based on this, I think, again, this right view that we are massively and radically epistemically dependent, and that we need to trust, right? Trust experts, trust institutions, and so on. And then the view is that, well, same with AI, basically, right? We don't really understand how AI works, but we depend on various, processes that we don't fully understand, or what, expert knowledge that we don't master, but we still trust them, and we should extend the same trust for AI. I think that these views are wrong-headed, okay? Just to make sure, okay. With the bounded rationality-based argument, so it's the story. So it's based on the view is that, okay, so if we accept the conclusions of the heuristic and biases program in cognitive psychology, then we have to accept that we're not nearly as rational as we think we are, right? Very often we make, decisions, judgments, we form our beliefs based on so-called system one, right? Different heuristics, many of them being unconscious, and these heuristics are very often biased in different ways, and these very often leads to irrational or unjustified beliefs, right? And sometimes we switch to system two, right? Rational, explicit, conscious deliberation, but very often it's just to rationalize the kind of outcomes that system one generated, right? So we make up a story after the fact to try to rationalize what system one produced, right? So this is well documented. It's hard to deny, right? If I want to work with what I call a non-ideal theory of human reasoning, right? As we reason, as embedded, embodied embedded animals, the way that real humans actually reason. I think that we have to accept, many of these conclusions. I don't see how we can deny them, and it's true that sometimes we are opaque to ourselves, right? We don't quite really understand what drives our decisions and actions. We are highly fallible. Human reasoning can be quite brittle. So, we talk about biases, we talk about noise also. Sometimes we're influenced by factors that are totally arbitrary, right? The judges his home team lost the day before, and now he's more severe in his decisions the day after, at the court. That's pure noise, right? So human reasoning sometimes is brittle. Or if you're hungry, for instance, right? It's not morally relevant, the fact that I'm hungry or not, but it can lead to, more harsher decisions. So all this, I think, is true.